for those of you guys just joining us. We're grading homework. I asked, first of all, were you allowed to use your calculator? You guys said yes, and I totally agreed, because who knows, 1.35. What's something that I would have known how to find the tangent of? You guys had some of those in homework. Look up earlier, before 14. Were there any ones that you should have been able to find tangent of without a calculator? Yeah, give me an example. What was 5? What was the problem? Why should you have been able to do tangent of pi over 6? It's on the cheater chart. It's on the unit circle, right? It's 30 degrees. Okay, so if you are allowed to do, or if you're able to do tangent of pi over 6, because pi over 6 is an angle in radians in your unit circle, you can't do 1.35. That's not pi over 6 or pi over 4 or pi over 3. But I asked whether or not, or how you should have known to be in radian mode. And some of you answered very interestingly. You said, oh, degrees are radians. And I agree for some of homework, but not number 14. Some of homework said, oh, yeah, give me degrees. Oh, yeah, give me radians. I don't care. Give me 1. This one had to be radian mode. Why?
Because the degree mode is so small.
That's something that your brain, Joe's saying like, oh, it's so small. But that's something that your brain could have been like, it's a weird answer. But there's always weird answers in math. Joe's saying it's a small angle, so we should ignore small things. Don't ignore small things. Horton here's a who. We should watch a movie. Anyway, so coming back, don't ignore the small things. Don't ignore the small people. Life lesson. I know, but I need why it has to be radian, not just I don't like small. It said in the directions? Oh, okay. Well, then they were way too nice. They told you radians, but if I just gave you this problem, I don't think I'd tell you radians on the test. And I know the test is far away. But why, just from the context of the problem, why does it have to be radian mode? Just from this, right here.
That's way too small of a degree.
No. But that's what Joe said too. And I said, we can't ignore the small people or the small things or just because we don't like them. We should think twice. I agree. I agree. I totally agree. With angles, not with, okay, come back. You guys just told me. No. Keep thinking. Hey, he's trying. Where are the rest of you guys? Pause. Didn't you just tell me you should have been able to do tangent of pi over 6 its unit circle? Who's this? It's an angle.
It should be 1 degree, 35 minutes or something like that. It shouldn't be 1.
We have good thoughts, but none of them are telling me why it has to be radians. And I'm not saying whether you're thinking, but Chris, they give it to you in radians, and there is no degree mark.
Okay.
Now, some of you were very, like, you wrote down the problem, and you're like, it literally said 1.35 radians. Okay, yeah, I get it. But they didn't have to tell you the word radians, and in the past, they haven't. When we were learning radians and degrees, remember how they would like throw out an angle and it's like, oh, it didn't have a degree mark. You guys should have changed your mode, right? Yeah. Whatever is inside a trig, sine of theta, cosine of theta, tangent of theta, secant of theta, cosecant of theta, cotangent of theta. Thetas are always what? Or angles. They're always angles. And so whatever is in that spot, you have to look and say, is he a radian or is he a degree? And you should know based on whether or not there is a degree mark. True? I know. The question said 1.35 radians. You guys are like, But I was able to look and know it was radians because there was no degree mark and it is an angle inside a tangent. Anyways, if you guys got this wrong, guess how you probably got it wrong? You were in degree mode instead of radian mode. Number 24. Number 24, this is a different type of problem. Maybe some of you guys got stuck. They gave you the slope this time, and you had to plug it in the M spot. How do we get to theta if a tangent is trapping it? Inverse, good. Tangent inverse. Have to use your calculator. Whoa! Why did they add pi? I thought you just did tangent inverse and you were done. Because an inclination must be positive based on section 10.1, defining an angle of inclination to be, hold on, wasn't it at the very beginning? A positive angle. So if you plugged into this to your calculator, it would have given you a negative angle, and so if you were in radians from this one, you would have had a negative radian. You would have had to add 3.14 radians to get the positive angle. But if you were in degree mode, you wouldn't have added pi. If you were in degree mode, you would have had a negative 38.9? Nope, a negative 37.9? You would have, okay. You would have had a negative angle, and you wouldn't be adding pi in degrees. What would you have been adding instead? You could have gone to radians and then added pi, or just added 180 to the degrees to get there, right? Once again, can inclinations be negative? No. So on the test, if I have in the multiple choice answers for an angle of inclination a negative answer, what should you completely and thoroughly ignore? Those answers, anything that's negative. Even though it's going to be crying out to you, being like, choose me, choose me. Anyway, you have to know it's an unwise choice and just say no. Life lessons all over the place. Number 28. 28. It's another way of writing tangent inverse. Yeah, you would do tangent inverse for arctan. Yeah. Guys, what formula are they using right here? This one had an extra step, right? Good, slope formula. y2 minus y1 over x2 minus x1. My distracted ones. Did any of you get confused at all as far as how to put these two together? No? They're like terms, right? Negative 2 of those guys minus 1 of those guys. Negative 2 minus 1 is negative 3 of those guys. And then we swoop, swoop. Why should you not have needed your calculator for... No, it's not. Square root of 3 over 2, square root of 2 over 2, 1/2. Oh, tangent. Square root of 3 over 3, 1. Ah, he's right there. He should have been a pi over 6. Nope, sorry, a 60 degree. A 60 degree, which is pi over 3. But wait a minute, why are they at 2 pi over 3? Oh, a negative means not the first quadrant. I had to keep going to the second quadrant. Good, 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 good. I agree. Number 32, did you guys get it into your slope-intercept form first? Steal your M1, steal your M2, throw it in, and then did you do what you were supposed to do? What did we see yesterday? Tangent inverse of both sides, right? Tangent inverse of the, did you have to make this pretty? Nah, you could have used your calculator. What's up, Lauren?
I thought I did this, but I just wrote the equations and then, nothing else.
And just, stopped?
Yeah.
Okay. Tangent inverse, and then throw the blah into your calculator. Then you should have it. Oh, we're done. Are we done? Yeah. Okay. Questions on odds or evens? Matthew. Or concepts?
So if you didn't want to change your mode on your calculator, could you do, if you want to switch from raised pi over 180 or 180 over pi?
Depending on which way you're going, yes. Yes, you could totally multiply by pi over 180 or 180 over pi, depending on whether you're starting from radians or starting from degrees. Anything else? We're okay? Do we realize that the directions dictate the way we have to go on these? And the givens dictate the way we have to go? If they give us 2 points, don't we have to find the slope first and then go to the formula? Right? Oh, because there's a typo in the answer key. What should it have been, Lauren? Wait a minute. Who's wrong? Is this one wrong?
Yeah.
Or is this one wrong? These are right?
Yeah, those are right.
Okay. So this is wrong. Lo siento. Good job finding the typo. Grad student needed more coffee. That should have been a 5th. And then this makes sense, and this makes sense, and that makes sense. Whew. Okay, anything else? How bad was that section? But what do you think is going to happen once we get to the end, after we cover section 10.2 for 2 to 3 days, section 10.3 for 2 days, section 10.4 for 2 days, and then our extra from another book section? We're going to forget, unless we make a note now as far as what was most important for this homework. What was most important for this homework? Formulas. M equals tangent of theta. Some of you have highlighted, some of you haven't. What else was important? Tangent, theta, angle between two lines formula, yeah? And then for just a few of you, things like, ooh, don't forget tangent inverse, or don't forget the y2 minus y1 over x2 minus x1, and maybe a quick little unit circle tangent backwards note. But otherwise, maybe we're good to go. Priscilla. No. Chapter 12. We're going to get a little bit into it. Honors Pre-Cal will get a lot more into it, but you guys will get a little bit into it. Section 10.2, not really a point to us looking at the evens yet, but can we peek at homework real fast? I know. It's not even due yet. If you guys actually looked on Google Classroom, I think I officially made it Friday. It's Friday on the board now. I think I made Google Classroom Friday also.
Yeah, it is.
Okay, good. Friday, wait, they're parabolas. I don't get it. Why are we spending another day and some more on this homework? Well, can we just peek at the homework real fast? Is that okay? These are vocab. They're theoretically going to be things that we talk about in class. Intersection of a plane and a double-naped cone, a conic section. Anyway, then we get down to the actual parabola-y things. You guys see the first section, right? The first section is saying, hey, here's lots of graphs, and then it says here are lots of equations. Okay. What do you notice about these parabolas that are a little bit different from the ones that you've seen before? Anything different? Anything new? Yeah, they're written kind of like flip-flopped, right? Usually we would have y equals x squared over 2 or something, but this is x squared equals. So that's kind of weird. They're flip-flopped. And not only is x squared, but what else can be squared? Y squared. Looking at these ones up here, which ones do you guys think are x squareds and which ones do you think are y squareds? Which one do you think come from x squared formulas? B, yeah, B comes from an x squared formula. What else? C. What's going to be different with this one? Not just an x squared, but a negative, and it's been shifted somewhere, right? This guy is also an x squared, but with a negative. But what are these guys going to be? Ah, because the orientation is sideways. Does that kind of make sense? So we're going to be working with, first of all, getting kind of used to what if the y is squared instead of the x is squared. But for you guys just to realize right now, okay, hold on. Well, the x squareds are our normal up and down ones. Maybe down, maybe up, but our normal up and down ones. Bless you. And what are our y squared going to be? Our side to side, or our right to left. Now, I think it's a pretty good clue that some of you realize that this one's going to have a positive and these ones are going to have negatives. Which do you guys think would be positive with our right to left ones? This one, what do you think? Positive or negative? Yes. And here's a silly way of remembering it. Hey guys, an upwards facing parabola, if this was a little Pac-Man, who would he be eating? The positive numbers or the negative numbers? Yeah, he'd be going towards the positives, right? This little guy, if he was a Pac-Man, which way is he headed? The positive way. Which way is this guy headed? The negative way. Even if he's shifted, you can still think about where is he headed. Oh, he's headed positively. Oh, he's headed negatively. Oh, there could be some life lessons in that. Anyway, coming back. We have x squareds, we have y squareds, but then look at the next section of homework. What else is new? Focuses and directrices and vertical axes and horizontal axes. Wait. We've talked about an axis for a parabola. Do you guys remember what the name is of the guy that goes straight through a parabola? Sometimes it's the y-axis, sometimes it's the x-axis, but look at this little shifted dude. Isn't his something totally different? Axis of symmetry. Good. Remember, symmetry is where we can fold, like a butterfly, where we can fold and then have one side copy the other. So we've actually seen this whole axis thing before. But focus and directrix, what? Okay, so we're going to talk about focus and directrix today. What else? What's the next section? Find the vertex. We've done that before. Complete the square. Focus. Oh, we're going to have to figure that. Directrix, we're going to have to figure that. Sketch the parabola. Okay, we're going to have to go from an equation to a sketch. And then I think the rest of homework, if we can figure out focus and directrix, and if we can figure out how to write equations, I think we'll be okay for the rest. Ooh, except for, what's this? That seems like a totally different type of problem, right? Doesn't give us graphs, doesn't tell us to find vertices or focuses. Okay, this is the one thing I don't think we're going to get to today, which is why homework is due Friday. But what does that mean we will get to today? Everything up to that. Does that make sense? So if you save for tomorrow night the entire section of homework, it might be a bit brutal. But if you work on the parts that you can, and if you realize what we're about to go over, the examples we're about to do are going to help you theoretically get up to like 56 or in the 50s, doesn't mean you'll get all the way there. And yes, you can give yourself some grace if you have youth group or something else tonight. But just a heads up, we're going to get to basically everything but this tangent line guy. Sound good? All right, let's go figure out who is a focus, who is a directrix. That's not where we're going. Lo siento. Okay. We talked about that. P.S. What is a sectioning or a slicing of a double-naped cone? A conic section is the first vocab in homework. All right. Bloop, bloop. Then we talked about this old school way of talking about parabolas. The vertex form where H, whoever goes with X, is the X value of the vertex, and K, whoever goes with Y, is the Y value of the vertex. Wait a minute. Guys, we just looked at these side-to-side dudes. Do side-to-side dudes also have vertices? Oh, yeah. They just have a point that's not going to be a max on top or a min on bottom, but is going to be a farthest right and a farthest left. But still, yeah, there's still vertices. Just the curvature goes a different way. Okay. So orientation of parabolas. This that we wrote was review, because those were the only types of parabolas we really worked with. But a quick heads up, if it's an up or down facing parabola, aren't we talking about when x is squared? Yeah? Because what we just talked about is, well, if y is squared, it's side to side instead. But the very end of yesterday, we had already looked at vertex form, already looked at orientation of parabolas. We were on this page. And this page was just starting to talk about there's this guy called a focus, and there's this line, kind of imaginary line, called a directrix. I know he's dotted, but he's not a horizontal asymptote. I know he's dotted, but he's not a horizontal asymptote. Or if my parabola was flipped, he's not a vertical asymptote. This guy isn't getting closer and closer and closer. Instead, he kind of shows like a boundary, sort of. The focus is a lot easier for me to explain to you. And I barely started at the very end of yesterday. Now over here to the side, I'm actually going to take all of this work that I did, I'm going to make it gray. So I don't think it's necessarily required for you guys to have memorized in any way, shape, or form, which is why it's not in the yellow box over here. But I did this work yesterday at the end of class just to show you where we've been versus where we're going. This is an example of vertex form. We could see the H, we could see the K, we could take the A, plug in a point, figure out how curved it is. We might have to use complete the square to make it look like that. But I was like, that's not the form that your calculator showed you for conic section of a parabola. So then we started moving stuff around, saying, okay, wait a minute, if the squared is supposed to be over here, I have to get rid of the A, I have to rearrange it to put the squared on this side. I want something in front of the y minus k, so instead of showing a division, I showed multiplication of a reciprocal to make it look closer. And then I was like, wait, I need a 4 in there? Yeah, 4. So whatever this dude is, he better be equal to 4p, and okay. I showed all of this to say we can go from how we used to write parabolas to how we now need to write parabolas, but we're going to have to do this little step, and this might be the one that you guys want to highlight or show. Whatever ends up being in this little coefficient spot, we're going to have to set equal to 4p to find our p. Because p doesn't even really have a name, to be honest. He's useful and he's necessary for the focus and the directrix. And I can describe what he is. He's the distance from, the absolute value of p, I should say, is the distance from the vertex to the focus, or the distance from the vertex to the directrix. P is the distance, it's the how far, but he is not the focus himself. He's just used to get the focus. And he's not the directrix himself. He's just used to get the directrix. And whole chapter 10a, you're going to hear me say over and over and over again, especially when clues like focuses and vertices and directrices, asking you to get equations, I'm going to say, have you sketched it? Have you drawn it? Some of you don't work visually, and I know that's really hard in math sometimes. And so I'm going to give you things like these big old charts of formulas that you can use, but the problem is, if this is how you do it, you're going to have to memorize them. But I'm also going to show you visual tricks to try to figure out the same information, but you're going to have to think carefully step by step, visualizing the graphs, labeling what I'm labeling in order to be able to fill in. Now the nice thing is, do you guys technically have to memorize these? It's in the Conic app of your calculator, so as long as you're able to use your calculator, you should know what the formula should look like, right? The problem is, well, how do I use the information to get there? Or how do I start here? Because you guys saw in homework, sometimes you're going to be given this, and you're going to have to go the other direction. So how do I go from having focuses and directrices, I should say foci, and directrices to equations or equations backwards? Okay. Let's start to bring this all together. If we have the x being squared, first of all, if we have the x being squared, I can say this is going to be either an up parabola or a down parabola. If it's an upwards facing parabola, well, did you guys remember I just barely started talking about flashlights yesterday? Yeah. I wish I had one of these old ones. I don't even think I own one of these old ones. Maybe some of your parents have some of those like big old hefty flashlights, like the what are they called, mag lights, right? The really hefty ones, especially if you go camping. And have you guys ever unscrewed the top of those? Yeah. Have you ever realized that what makes the flashlight beam go is a parabolic reflector, like a mirror, right? And if you look at that parabolic mirror, I think I even have a picture of it. There's usually a light bulb, especially in the old ones. The newer ones, they start having like all these LED ones. But if you have, like if you open up that flashlight, there's usually a parabolic mirror, and then there's like a little light bulb. And they put that light source at the focus so that it will hit that parabolic reflector in a way that all those beams go straight out. What's the difference between a flashlight and a lamp? If you just put the light, then it just diffuses everywhere, right? Not literally everywhere. Like, well, yeah, it spreads out everywhere. The light bulb will just go whoosh. But a flashlight focuses the beams, right? And doesn't let it, the parabolic reflector doesn't let it just go wherever it wants. It focuses the beams, but you need the light source to be at the focus. The focus is easy for me to describe to you. The directrix is kind of like, who's he? Well, he's this line that's out there that's kind of imaginary. The same distance away. Okay, the directrix is kind of weird. He's a line, but the focus at least is a little bit more concrete as far as a concept. But that helps us, though, because then we know if we can figure out which way the concavity is going, where's the focus always going to be? Inside the parabola. Does that make sense? Now, we don't really have to stress about how far, because the how far is what that little p guy is going to help us with, as far as the actual distance, as far as like a quantity. But the focus is always going to be inside, and not just inside, but a certain set distance away from the vertex. And then the directrix is always going to be the other direction. He's always going to be outside. And so if I have an up-down, if I have an x squared, my directrix is going to be a line that's outside. My focus is going to be a point that's inside. I can do the same thing with y squared, except now I'm going to have a parabola that's headed to the right or headed to the left with a focus that's on the inside, a directrix that's on the outside, or headed to the left with a focus on the inside and directrix on the outside. That's just kind of like a quick little, oh, okay, so how my parabola is oriented. I put the focus inside and the directrix outside. So all of that to say, horizontal lines are always y equals. Vertical lines are always x equals. And so if we take all these guys away, our directrices are going to be lines, and our focuses are going to be points. Our directrix can say, if it's a y equals, take the k from the vertex and take away p. If the directrix is a vertical one, x equals, steal the x that you have, h, take away p. So actually they're very similar, they're just the lines are different directions. So whether it's a y or whether it's an x depends on whether it's horizontal or whether it's vertical. And you can read that here, vertical or horizontal axis. Steal, whoever you already know, either steal the y if it's a y or steal the h if it's an x. Take away p, but the focus is a little bit different. If I have for the focus, if I have my x minus h quantity squared equals 4p y minus k, my focus is going to say, take the h and take the k, and see how we're subtracting from the y? We're just going to add to the y instead. We're going the opposite way. And since it's a point, the x stays the same. The y changes. So whether you're doing a directrix or a focus of an up-down parabola, you're messing with the y either way. But one way you're taking away the y or taking away from the y, and the other way you're adding to the y. You'll see it as we do an example. But the nice thing is, if you kind of follow that pattern, you might be able to fill this guy in without me telling you anything. Anybody have any ideas about what the focus is going to be if everything's oriented the other direction? We are adding p, but to who? To the h, yeah. The focus goes the opposite direction of the directrix. So if the directrix takes away from the y, fine, the focus adds to the y. If the directrix takes away from the x, fine, the focus adds to the x. There's a pattern to it. But to be honest, I think this will make a lot more sense for most of you if we start putting pictures and actual details to it. But once again, vertical axis, in case it helps. We're talking about a vertically oriented parabola with an HK, with a vertical axis, where we can subtract from the y to get our directrix, and we can add to our y to get our focus. And I could do the downwards, but then it just starts getting really confusing. And a horizontal axis, we have a right-left with an HK. And we're going to subtract from the x to get our directrix, and we're going to add to the x to get our focus. So with that, boop. Oh dear. I'm going to tell you draw a picture. I'm going to tell you draw a picture. Do you guys want me to go back on this page real quick in case I lost someone? Did I lose anyone? Do you guys need to take a picture of it? Yeah. It's going to be helpful to stare at it, at least in the beginning. And some of you, to be honest, it's going to be helpful to memorize. Yeah, Matthew's already starting to think about this one. We have pictures? Okay. Graph what you know every time. Write down, summarize. What's the long, this is the long version. What's the short, sweet version? Find parabola with vertex at the origin, focus at 2, 0. Okay. If your brain is starting to be like, wait, I can plug in things, keep very silent and start plugging in things. If your brain's like, wait, I can start plugging in things, perfect. Keep totally silent and start plugging in things. See if you can get there before me. For the rest of you guys, let's graph stuff. So if the vertex is at the origin, what's the point? 0, 0. And the focus? We have 2 points to graph, true? If the Pac-Man or the parabola is eating the focus, or if the bulb needs to be inside the parabolic reflector for the flashlight to be of any use. Do you guys see how the parabola has to be oriented to the right? Right? It's the only way. The light won't help, the light won't help, the light won't help. I need the light to be inside the parabolic reflector to help. So I don't know exactly, I'm going to do it like in gray. I don't exactly know how curved he is right this second, but I do know, okay, he has to be at least this guy. He's somehow sideways, right? So pause. Which standard form am I trying to plug into? As soon as I attach to, oh, it's headed right. Okay, if it's headed right, is the x being squared or is the y being squared? Good. So why don't we go ahead and tell our brains where we're headed? We want to head here. You guys agree? If we have no idea what we want to get at the end, the odds of us getting there is very slim. So we start off saying, okay, that's where we're trying to go. Where can I put 0, 0 right away? Careful. In the x and y spots of the vertex, meaning the hk spots. Good. hk is my vertex, right? So I can plug in y minus 0 equals 4p times x minus 0, just plugging in my vertex clue. Oh, I didn't write it? We should sue. Just kidding, don't. Okay, so we could start simplifying, but hold on. Right now, this form is perfect because this form shows there's the vertex and here's the, who's this guy again? He doesn't have a name, but what is he? He's the distance, go look at your picture if you need to. He's the distance between the vertex and the focus, between the vertex and the directrix. Now, we don't have the directrix right now, but we do know the focus. So shouldn't we know what P is? P is what was, if you need to, go look at your focus for the y squared. P is the guy that was added to the h to get to the new point. So kiddos, what was added to the h to get to the new point? Oh, sweet. So P is equal to 2. So therefore, I can say y minus 0 is y squared equals 4 times, I can plug in, P is 2 times x. So I can get y squared equals 8. And if you guys noticed when I was in the book just a second ago, remember how you guys said that they were written weird? It's okay to keep them written weird because it's actually written the normal or the standard way for conic sections. P is the distance to the focus. P is the distance to the focus. And you would go the opposite direction for the directrix. Now, did they ask us to find the directrix? No. But where would it be if they did ask us? They didn't. They just wanted the standard form and we're done. To the other way. Yeah. So we can put in parentheses, be like, yeah, we're amazing. We know what's going on. The directrix would be, wait, to the other way. We can draw it. It'd be a vertical line, right, guys? Is that an x equals or a y equals? Good. We're adding and subtracting from the x, if they were to ask us, but they didn't. Now, hold on. This looks really weird until you realize the ... means steal everything up until direction. Yeah, instead of it, wait. This can't be that problem, right? Yeah. Because we just found it. The directrix was x equals negative 2. Okay, so I was just being super lazy. Still have the vertex at 0, 0, but instead of this clue, now the clue is changed. Does that make sense? I know, I was being lazy. I should have written all that stuff over again. But find the standard form of the equation of the parabola with vertex at the origin and directrix at y equals 1. So can you guys take a second and draw our clues? Try to think about which way the parabola would have to go, because if we can figure out which way the parabola goes.
No, it goes down.
Okay, draw. We just got like every possible orientation besides right. Draw it, and then think about what's the only way your Pac-Man could be going. Do you guys agree with the standard form I chose?
I agree. Yeah.
Which one did I choose, the up-down or the right-left?
Up down.
The up-down, but why? Y equals, isn't that a horizontal line? Do you guys notice that if we were to go here and draw all these out, did the Pac-Mans ever intersect the directrice?
No.
Or the directrix? No. It always had to be going away from the directrix, which means if I was to graph this guy and graph his vertex, could it be going right? No. Could it be going left? No. Had to be going down. Right? Had to be going down. Now, if we wanted to be amazing, we could actually show the focus right now. Do you guys know where the focus would be? They didn't give it to us, but we can show it. Why would it be 0, -1? Joe is totally right. How did he know that? Opposite direction of the directrix. Good. Opposite direction of the directrix. And we figured out that it was an up-down one, right? Now, I don't know totally, without digging a little bit deeper and finding extra points, which we couldn't do until we find our equation. I don't know exactly how curved it is, but I do know somehow it's a downwards facing parabola, right? Okay. What can I plug in right away? H and K, because my vertex always gets to go. Oh, sweet. It's easy if we can figure out the proper form. Now, guys, what did I just leave blank? Do you remember what I said about P? Distance to, now the absolute value, it's the distance to the focus directrix, not caring what direction. But I specifically said it's the distance to the focus. What should you always do in class?
Focus?
Yeah. So what's P? Go to the focus, right? Careful. It's not 1. -1. Go to the focus. How do you get to the focus? Down 1. Now, the absolute value, it is a distance of 1. It is a distance of 1. How far? Go 1. How far? Go 1. But to the focus, where's the focus? You have to go down 1. Does that make sense? Maybe. Now is a good time. If you just saw that and you're like, ooh, I would have put a positive 1. Get back here and make yourself a note about the P. And say something to the effect of, P is always the distance to the focus. And you might want to put some sort of note about dependent on the direction. If you're headed positively, it's a positive. If you're headed negatively, it's a negative. But it's always to the focus. The directrix just goes the opposite direction. But always to the focus. Wait a minute, aren't we done? Basically, isn't x minus 0 just x? And a negative times a 4 is a -4, and y minus 0 is y? Dun, 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 dun. And we technically found the focus, even though we didn't need to. Cool beans?
Yeah.
So what if, remember, we looked at those directions and they changed a little bit, right? Could you memorize this whole page, every single possible orientation of parabolas and what would result as far as the focuses and the axes and the directrices? You could. But do you see how I didn't really make you memorize much of anything over here? We're just following the clues, understanding how parabolas work, and what this thing is that's called a focus, what this thing is that's called a directrix. Now, hold on. What was important to memorize? Yeah, if we didn't have this to plug into, we'd be in trouble. And then we had to talk about who's P, right? who's this little coefficient guy with the 4. But it's up to you. Some of you might need to memorize this. Take a picture if you're like, I think I might be one of those people. No judgment. It's fine. I get it. I have kids that have gone all the way through like STEM majors and become doctors who thought like this. It's okay. If you need to memorize, memorize. But some of you are like, nah, I can problem solve my way through it. To some extent, people that have to memorize do better in science majors because it's all about memorizing. You can't get through a bio degree without memorizing. It's impossible. Come back. A lot of reading and a lot of memorizing. Okay, what about this one, guys? What about this one? Okay, you're thinking a lot of good things, but what do you think I'm going to tell you right now? Draw it. Go. Draw it. I know they're not telling you to draw it, but I'm telling you to draw it. Draw it, because then maybe you can get a standard form and start plugging in stuff. Draw it. Hey, this is from the 50s. This is like from the end of homework. Huh. There's stuff in between, but that's okay. Why did I use that standard form? Different ways. It's horizontal axis if that's how your brain thinks, or my parabola is going to the, specifically to the right. Isn't that the only way to get the little flashlight dude and to not hit him? Anything else is going to hit him. Definitely hit him. Okay, so if that's, wait a minute. Jason made a good point. He was like, they didn't give me a vertex. Well, who's my H and who's my K? Figure it out, because don't you go a p distance one direction and a p distance another direction? So don't I just need to find the midpoint? What's the midpoint if it's 2 there and 2 there? 0, but in the middle, right? X is equal, oh, but it has to be up here, because if it's down here, I have some issues. I have a straight directrix, which means, aha, there he is. I'm going to put him in gray. I don't exactly know his curvature, yada, yada, yada. But somebody like this. Okay, now, if that's true, can't I now say I figured out that my vertex is at 0, 2? So I can plug in y minus the y value, 2, equals 4 times x minus 0. Some of you have already figured it out, but who is my p? Positive 2. Why'd you say positive 2, Matthew? The distance, good, is 2 in the positive direction to get the focus. Positive focus. Oh, some more life lessons I have to skip. Y minus 2 quantity squared equals 8x. Could we like foil it, and could we get it all to one side, and could we make it look totally different? Yeah. But standard form, it's okay. You guys saw in the book, there's some weird ways of showing it. So what didn't we get to today? The tangent line thing we didn't get to today, but what else didn't we get to today? Well, let me show you just real quick. Oh, we already did that. Oh, that's my tangent line. Wait. We said we were skipping that. Thank you. You guys see these are the 30s and 40s. We just did an example from the 50s. Well, if there's 30s and 40s like this in between, maybe we should pause and take a quick peek at these. What's different in these directions? They give you the formula. Wait a minute. Wait. If they give you the formula, go backwards. The y is squared, right? Wouldn't this have come from the y minus k squared equals 4p times x minus h? Go backwards. If there's no plus or minus, what must hk have been?
0.
Got it. So if hk was 0, then it would have been y minus 0 squared equals, wait, who's in front? 3. So 4 times, how am I going to figure that? take him off to the side. Don't take the X though, just the 3. Take him off to the side and say, you had to have come from this. He had to come from 4p. What's the only way he could have come? Well, solve. Yeah, divide by 4, divide by 4. P must have equaled 3/4. Haha. How does that help me? Well, we already figured out our vertex. Yeah. We know our vertex. We know it's a y squared, which means it's a right-left, and I know it's right because it's positive. Positive, right, there's a whole life lesson there too. But anyway, we know it's going to be right-left. So where's my focus going to be? To the? How far? So my focus is going to be right here at 3/4, 0. And my directrix is going to be? X equals -3. Check it. Did I just find everybody that I needed to find? My focus, my vertex, and my directrix. And a sketch. So what's harder once you get to the 40s? It is, but can I at least show you the way? Pause, you can pack up. Can I at least show you the way I would go? You guys can check it out in the video and you can say, wait a minute, I think I can do that too because all I just did was complete the, oh, no? Come on. Complete the what? Since Algebra 1. I completed the square to make it look like my standard form and then I would be good, golden, solid, ready to go. Bye guys, see you later. Nice thing is homework is totally due tomorrow, but you better get in and be practicing. This is a lot to keep straight.